Good morning to everybody. My name is Tiziana Cavalieri and I am one of the conservation scientists working at the Venaria Reale Conservation Center, a few kilometers from Museo Egizio. First, I would like to thank the organizers for creating this opportunity to connect people on these current topics and for inviting me. Indeed, I'm so sorry not to be there in person, but now I am at the end of my pregnancy. How do we make objects talk is the title of my speech because in my job I feel like a psychologist when I analyze an artwork trying to make it talk about itself, trying to capture information for knowing its history and its manufacturing. In fact, a lot of information can be stored in the materiality of an archaeological find, as the Museo Egizio explained excellently in the past exhibition Archeologia Invisibile. For example, the black and white photographs documenting the archaeological excavation are very precious for us since they show us how these objects were transported from the excavation site. However, it's namely the materiality of the object, in this case, its still intact decoration, that allows us to recognize this item in the historical picture. Sometimes the materiality of the object may contain information on its arrival at the museum, as in this wooden statuette, where the catalog number was even painted directly on the wood instead of using a label. This means that, in general, observing the object carefully under a suitable light or with a lens is the first step for starting this process of knowledge of the artifact through its materiality. In this complex process of knowledge, numerous professionals are involved. Usually there are archaeologists, Egyptologists, art historians, conservators, curators, scientists with different specializations, everyone making their contribution. After a close observation of the object, the process requires to collect archived data and historical documentation, to make a bibliographic research on the context, the period, the author, the comparison with similar objects for a stylistic study, and the acquisition of material and technical data. Especially from the scientific analysis, we can extract a lot of material and technical data. So the role of the conservation scientist in this process becomes crucial. Moreover, more and more data may emerge if we can analyze an object with a conservator during a conservation treatment. The reason is that having the time to observe the object and interact with its materiality, for example, for a cleaning treatment, like in this picture, allows for a clearer vision of the original material and often provides greater possibilities to carry out small sampling for the microinvasive analysis of the material. So when many professionals and institutions work around the same object, it is extremely important also to exchange information between all the people involved and have a person responsible for putting this data together. On this topic of exchange and communication, the conservation scientist should have an advantage since he is a figure born precisely as a connecting people between the humanistic world and the technical scientific one linked to cultural heritage. In fact, we have received a blended training with chemistry, physics, natural science, archaeology lessons that hopefully should help us to communicate on multiple levels with different professionals. When we can work with an interdisciplinary group that is the best situation for knowing an object, we usually receive multiple questions from each professional. From this list of questions, our first duty is to refine the list, because sometimes, based on the state of the art of the diagnostic techniques, some questions are impossible or extremely difficult to resolve. Then, for the possible ones, we have to identify the most suitable scientific analysis to do. That is, drawing up the so-called diagnostic protocol, also with a forecast of the time and cost of the analysis. Luckily, today, there are several analytical techniques available for archaeometry. Each conservation scientist, based on his background and instrumental equipment, can personally carry out the analysis in which he or she is an expert, but he has also the duty of identifying and interacting with possible partners who can carry out the other analysis deemed necessary. I think that how much to deepen the understanding of an object should not depend on each laboratory's equipment, but rather on the advancement level of research in the scientific community. For this reason, a conservation scientist should know the potential and limits of all analytical techniques in order to identify the best collaborations for answering that list of questions and be able to contribute to stimulating the development of new instrumentation and opening new lines of research. This is the example of the diagnostic protocol of the Vatican Coffin Project, an international project led by Dr. Alessia Menta of the Vatican Museums. With different international partners, the Vatican Coffin Project is a beautiful example of an interdisciplinary group, because we are Egyptologists, conservators, and conservation scientists working together to study polychrome wooden coffins from different museums and collections, to deepen their construction and pictorial technique and identify any atelier. Here, the diagnostic protocols follow the 3 steps of the diagnostic campaign, based on the application of different methods, from the imaging techniques to non-invasive to micro-invasive analysis. Once the protocol is defined, it is our duty to respect this sequence to reduce the number of samplings and guarantee the best reliability of results. Let's look together at some examples relating to coffins to understand how scientific analysis can contribute to their knowledge. For studying the wooden structure, X-rays and CT scan certainly prove to be very useful for understanding the assembly technique in detail, especially when the surface is fully decorated and painted. In this example of a coffin box, we can see not only the original axis, but also the metal screws applied in modern times to reinforce the structure. Information on past interventions is always of great help in understanding how to realize a new conservation treatment, and also in discriminating against the original materials and techniques. For studying the outermost layers, UV fluorescence is particularly useful and adopted to locate traces of past interventions. Here, one of the questions of the list was to localize and identify possible substances used in past conservation treatments. This whitish UV fluorescence actually showed the presence of adhesives, probably of synthetic nature, applied in modern times. I chose this example because often, when we try to answer one question, others always come up. Beyond the adhesives, what stands out in this image is this bright yellow fluorescence in correspondence with the wooden dowels between the axes. At the beginning, we thought it might be another synthetic substance, so we asked to analyze a microsample from one of the towers. However, FTIR spectroscopy only detected the signals of traces of vinylic substances which cannot have this fluorescence, and signals of the wood. Going ahead with the research, we learned that one of the wood species most used in ancient Egypt, the acacia wood, has this yellow fluorescence, so this yellow is of the wood. Studying other coffins, we noticed that the use of acacia dowels for assembling the sycamore boards of the coffins was actually quite common, perhaps because acacia is more resistant and suitable for this function. Scientific analysis allowed for discovering also something interesting about the preparation layers. The X-rays sections shows this thickness very well because the organic layers are more radiopaque than wood. The expected scheme of the stratigraphy of a wooden polychrome coffin is reported here. The wood, a covering or filling material to make the wood homogeneous, a white preparation, and the polychrome decoration. Studying several coffins with microinvasive analysis, we recognized the presence of ground layers different in color and grain size, but with the same overlapping. At the beginning, we thought they might be a mixture of calcium carbonate with red or yellow ochre, but minor spectrographic analysis allowed for supposing the use of raw grinded materials, such as limestones, naturally colored. Probably the Egyptian artisans added also an organic binder to hold the layer together, but we couldn't confirm this evidence yet. So the interesting outcome of this research, conducted in collaboration with the Earth Science Department of the University of Turin, concerns not only the material of the coffins, but also the analytical technique used. The minor petrographic analysis, which is usually applied to rock samples as they are, showed to give important results even if applied to polished cross-sections. Many of the coffins of the Museo Egizio collection arrived at the museum covered in a black layer, probably due in part to the fire of the tomb of Provenance and in part from deposits of dirt. To clean them with a conservation treatment, it is important to know the composition of this layer, because it can only be removed if you are certain that it is not original. In some coffins like this, it was possible to verify that even the original red varnish had transformed, becoming very dark and completely hiding the decoration. Since it could not be removed, only scientific analysis could have helped us recover the inscription. This is a very surprising example because as there is no carbon inside the layer, it was sufficient to acquire a photographic infrared image to recover all the hieroglyphs and inscriptions and the decorative apparatus. Hieroglyphs and decorations which could not be recovered through restoration were therefore virtually recovered through technology. Furthermore, on other coffins like this one, the investigations initially focused on restoration problems allowed for digitally reconstructing the polychrome decoration of the surfaces. Also here, polychromy and hieroglyphs were hidden by a blackening that could not be removed. And in correspondence with some gaps, the decoration scheme appeared very accurate and detailed. This macro XRF correlation map shows the distribution of iron, arsenic, and copper, indicating red ochre, orpiment, and copper-based greens or blues. For the additive synthesis of color, the yellow pixels indicate the concomitant presence of iron and arsenic, suggesting a possible mixture of red ochre and orpiment. In correspondence with the copper signal compatible both with blue or green copper-based pigments, the visible induced luminescence image allowed us to localize the presence of Egyptian blue and to imagine a green decoration for the other pixels. Putting all this data together, it was possible to reconstruct the colors of the goddess, those of the wings, and the geometric decoration. Finding colors completely disappeared, such as green and blue, and unexpected, such as orange. The last example I would like to show you regards the study of the tomb of Cain Merit in the framework of the TT8 project. This tomb was recovered by the Italian archaeological mission led by Ernesto Schiaparelli, and it is considered one of the greatest archaeological discoveries of ancient Egypt. The objects found in the tomb are exhibited in a dedicated hall of the Museo Egizio. At the start of the project, our team of Venaria Reale got involved in the study of all the items of the tomb with multispectral imaging and non-invasive analysis. Currently, a set of wooden polychrome caskets is under complete investigation, propedeutics to a conservation treatment. During the preliminary investigation on these caskets, the team of Dr. Paolo Romano from the Institute of Cultural Heritage of the CNR discovered, with a macro and micro XRF scanner, the unexpected presence of a manganese-based pigment, especially distributed in correspondence with black decorations and hieroglyphs. In particular, on one of the caskets, the map was surprising for the number of details made with manganese. Manganese on this casket seems to correspond to very subtle details as a finishing touch to complete first setting profiles made with carbon black. For this reason, we went ahead with the research, adding questions to the list in order to understand if manganese black was used consciously instead of the most diffused carbon black due to specific reasons, and investigating which could be the reasons for using it and how widespread was it. This insight has consisted of studying the supply sources of manganese-based minerals, which were actually available in ancient Egypt, and of a series of tests for evaluating the different performances of the two classes of pigments when used for painting or writing. They showed, in fact, some differences in the preparation process, which is easier and faster for the manganese black, and, for example, we noticed a poor mechanical resistance of the manganese paint if spread in more than one layer. Another step of this research was to look for an alternative method to macro XRF to allow faster discrimination of black pigments, something like a photograph that could help us investigate quickly several objects of the collection to understand the real diffusion of the manganese black. The method is based on the optical spectral difference between manganese black and carbon black in the short-wave infrared, which has a maximum in the 14-1700 nanometer range. So, to enhance this difference, we used an InGaAs camera with a long-pass filter at 1400 nanometers. After some tests on mock-ups, this method was applied to the wooden caskets with very good results. This is one of the caskets, the elemental map of manganese from macro XRF analysis, the image acquired in the infrared range, and the fourth color image, where the areas painted with manganese black showed a red false color in contrast to the black false color of the areas painted with carbon black. I would like to conclude with thanks again to the Museo Egizio, which has always involved us in interesting projects and with an open-minded approach to research. For all of us, access to museum collections is fundamental, as it can promote the study of more artworks by the same author or series of objects, allowing for collecting important comparative data to enhance the potential of this process of knowledge of the objects through their materiality and scientific analysis. Thank you all. Thank you very much for your attention.